Okay, everyone, we're going to review the review sheet so we're prepared for the exam that we're taking tomorrow. So first we have the x-intercept. The x-intercept is the point where a line crosses the x-axis. Now for our reference point, what I'm gonna do is I'm gonna draw a little graph for you over here. Let's say this is our graph right here. Now let me make that a little more neat for you guys. So let's say this is our graph, this is our x-axis, this is our y-axis. And let's say we have a little line that goes like this. Now the x-intercept is where the line that we just drew crosses the x-axis, which would be right here. So I'm going to highlight that in blue for you. This here is our x-intercept. Now, similarly, our y-intercept is the point where a line, now I'm going to add another word here. First we said crosses, I'm going to say intersects, which also means crosses, the y-axis. So if we look at a little model again, this here is our y-axis right there. So the line that intersects it would be right, would be right over here. So I'm gonna plot that right here. And this here would be your y-axis, sorry, your y-intercept. It's the y-intercept because it intercepts the y-axis. Now, speaking of, we just talked about these. We have the x-axis. The x-axis is the horizontal line in your coordinates plane. We also refer to as a graph. So right here, this here would be our x-axis, the horizontal one. I'll give that a big highlight in blue. This is your x-axis. And then again, the y-axis is similarly the vertical line in your coordinate plane / graph. And that is right here. Highlight this one for you as well. All right. Inequalities. Now, we talked about this a little while ago, but inequalities are values that may not be equal, so are not equal, or sometimes they could be, but they're usually greater than or less than. So that's when we see the signs like greater than, we have less than, we have greater than or equal to, less than or equal to, we have not equal to. So these are some of the inequality signs you might see. And then we have linear equations, which include forms. So we talked in class today that linear equations, they typically represent a straight line They have a constant rate of change. And two forms we've seen them in, we have our slope intercept form. This is one of the most common forms you see it in. Intercept form, which is y equals mx plus b. And then we have our standard form, which is ax plus by equals c. Now, these are both linear forms. They're just written in different ways. Okay, moving on to slide number 2. This is question number 2 from the review sheet. If the function of x is equal to 7x plus 25, what is the value of the function of -8? So this, they're giving you here an input value, and they want you to find what's the output. So the goal here is to find what is the output value when the input is -8. So what we do is first I'll rewrite our function. The function of x is equal to 7x plus 25. Now what we want to do is we want to plug in the function of 8. So the function of, it's -8. Anywhere we see an x now, we're going to plug in that value, -8. So this was 7 times x. Now it's going to be 7 times -8 plus 25. So now the first thing we're going to do is we're going to follow the order of operations, and we're going to do 7 times -8. And what this gives us is we're going to keep writing this function as we go. The function of -8 is equal to 7 times -8 is -56 plus 25. Now we're going to keep going. We didn't find what the value is yet. So now we're going to do 56 plus 25. So the function of -8 is equal to -31. When your input value is -8, the output is -31. I'm going to write that out. So, because we want to see answer statements, when the input of the function of x is equal to 7x plus 25 is -8, the output is -31. Another way we can write that is the input is -8, the output is -31. Awesome. Next, find the solution to 3x plus 4 is less than x minus 14. So here we are solving an inequality because there's a less than sign. So 3x plus 4 is less than x minus 14. Now again, our goal is to get our variables by itself. So we're going to treat this just like it was a regular equation, and we're going to solve for x. The first thing I want to try to do is get all my constants to one side and all my variable terms to the other. So the first thing I want to do is subtract 4 over here, because I want to bring this to the other side and combine it with this -14 over here. Now you could have subtracted 14 as well. Either way is fine. So if you subtract 4, you're going to do 3x is less than x. Now we have -14 minus 4, and that is -18, making this x minus 18. Now, did I get my variable by itself? Nope. it is still being subtracted by 18. So I need to get that variable by itself. So over here, I have a variable term, I have a variable term, and I have a constant. So I want to get all the variable terms together. So since I have a variable over here and a variable over here, I'm going to subtract x to both sides so I can have all my variables on the same side of the inequality. Subtract x here. We have 3x minus x. That is 2x is less than, I bring down this negative 18. Now do I have x by itself? Nope. It is still being multiplied with 2. So I'm going to divide by 2 to both sides to get x by itself. 2x divided by 2, that leaves x. Negative 18 divided by 2, that is negative 9. Now, if you guys remember, there's a special rule for inequalities. And that's going to actually answer that second question. What is the special rule when solving inequalities? So that rule is if you multiply or divide by a negative number, you must flip the sign. But again, this is only if you multiply or divide by a negative number. So let's take a look here. What do? We divided by positive 2. So because we divided by positive 2 to both sides, what we have is x. We don't change the sign. We have x is less than negative 9. Okay, so now we can move on to the next question. Oh, let me take another look. Right, so here we're saying x is less than negative 9. That means if we want to write a statement, I'll do this in a different color. X is all values less than negative 9. Okay, so we talked about this in class today. We have here a graph. Describe if the following graph is linear or not. Explain why. So here I see a graph. I see a graph that is going down and curving and going back up. So this here is not a linear line. If you remember earlier, we said linear lines have to be straight. So this line is not straight. And it has to have a constant rate of change. Constant rate of change. So this is not straight. And the rate of change decreases, then increases. So this is not a linear line. So our statement could be, it's not a straight line. And does not have a constant rate of change. Okay, here we go. We have another one. Describe if the following graph is linear or not. Explain why. So here I see a graph. If I look from it from left to right, it seems to be a straight line. We are good there. And from left to right, the graph is decreasing. So here we have a linear function. It's linear because it is a straight line. And it has a decreasing slope. And we know it's decreasing because the line from left to right goes downward. So since it's going down, it has a decreasing slope. Or the right word isn't decreasing. It's decreasing from left to right, so it has a negative slope. My bad. My apologies. It's a negative slope. Next question. Okay, we have here another graph. While when we look at it, it looks like it could have been a straight line, but then it starts to curve upward and start going up. Clearly, this is not a straight line. So it's not this is not linear or nonlinear because it is not a straight line. Next. Oh, so this was not linear, non-linear. We're at 4D. Describe if the following graph is linear or not. So we talked about this one today. Now from this one, it looks like it's a straight line. I'll write in green. This is a straight line. But there was an issue with this. So let's say we'll take out 2 points from here. This here is 2, 0. That's 1 point. Let's say 2, 0. And this one here, let's go with 2, 5. Those are 2 points on this graph. If I do, I'll rewrite them here, 2, 0, 2, 5. If I do my slope formula, which is m is equal to y2 minus y1 over x2 minus x1. Let me start labeling those coordinates. I have x1, I have y1, x2, y2. Then I plug them in. So y2 is 5 minus y1 is 0 over x2 is 2 minus y2 is 2. Sorry, x2 is 2 minus y1 is 2. And that gives us 5 over 0. And as we learned in class today, you cannot divide anything by 0. That makes it undefined. So this is an undefined slope. Since it's an undefined slope, you cannot, it cannot be considered linear. So this is not linear or non-linear. Next. Now here we have another graph. It is what we do notice, or what do we do see, is that it is a straight line. It is in from left to right. From left to right, the graph is going upward. So from left to right is going upward. If it's going upward, it's number one, it's a straight line. And since it's going upward, it has a positive slope. So since the slope is positive, it is going upward. That makes this a linear line. Okay, so now we're going to go back to what we were doing last week. We have the value of the x-intercept. Here we go. So if we're looking for the x-intercepts, the first thing we do, 3x plus 5y equals 60. You have to rewrite the equation. And something we can remember is that at the x-intercept, the value of y is equal to 0. So what we're going to do is we're going to rewrite this equation, and everywhere we see y, we're going to plug in 0. 3x plus 5 And now we have a y there. We're going to plug in 0 times 0 equals 60. Now what we're going to do, if you look at this equation now, we only have one variable. Since there's one variable, we know we can solve for that x. We're going to continue. We have 3x plus 5 times 0 is 0. So that it cancels out. It becomes 0. We don't have to write the 0. This is equal to 60. Now all we have to do is solve for x. We have 3 times x equals 60. We're going to do the inverse of multiplication. We're going to divide that 3 to both sides. X is equal to 60 divided by 3 gives you 20. So our coordinate is for the x-intercept is 20, 0. The value of the x-intercept is 0. Nope, what am I saying? Is 20. So similarly, with the same equation, they want us to find the y-intercept. So a fun fact about the y-intercept is that when we are at the y-intercept, x is equal to 0. It's the opposite of the x-intercept. So what we're going to do now is everywhere we see x, we're going to plug in a 0. So we have 3 times 0 plus 5y equals 60. 3 times 0, that gives us 0. I'll write it this time. 0 plus 5y is equal to 60. Since this is 0, we don't have to write it again, so we can get rid of this. So 5y is equal to 60. Now to solve for y, we have to divide by 5 to both sides to get y by itself. Y is equal to 60 divided by 5 is 12. So the value of the y-intercept is 12. And then we can write that as a coordinate. So since our x is 0, our y is 12. Next question. Okay, now this one I heard a lot of people struggled with, so we'll try this one. Gemma is driving from her home in New York City to Los Angeles, California. The table below shows her distance from home as a function of time. Here we have time, here we have distance. Now I know we said in class today that they don't tell us which is x and which is y. So typically, this is where we have something called an independent variable and a dependent variable. The independent variable is the one that we have no control of. And the dependent variable is the one that's affected by the other. For example, we do not have control of time. Time moves on, rather whether or not we try to stop it or not. But distance, we can control how fast we go sometimes. So time here is our independent variable, and how far you go, the distance you travel depends on your time. So the reason we said this is because independent variables are typically represented by our x, while dependent variables are typically represented by our y. But if we remember this, if we look at a table, all we can see that this is X, this is Y, and the question is asking us, determine the average rate of change between hour 3 and hour 10, include units. So if we take a look here at hour 3, we took a look at hour 3, we drove 165 miles. So we can write this as a coordinate. We'll have 3, 165. And then at hour 10, we drove Gemma drove 750 miles. So Gemma drove at 10 hours, drove 750 miles. So all we have to do now is, because we are looking for the rate of change, we know that formula. The formula for the rate of change, I'll write over here, rate of change is equal to m is equal to y2 minus y1 over x2 minus x1. Now I'm going to label my coordinates. x1, y1, x2, y2. And now we're just going to plug it in. We have 750 minus 165 divided by our x2 is 10 minus our x1 is y. Sorry, our x1 is 3. And now if we do this, we do 750 minus 165, and that gives us 585 divided by 10 minus 3 is 7. Now what this is saying, before we go any further, what this is saying is that they drove 585 miles over 7 hours. Why am I writing units? Over 7 hours. So this can be simplified even more. So let me see if I can move this. Let me move this up a little bit, maybe make it a little smaller. Oops. Let's try that again. Yeah. Okay, gonna make it a little bit smaller. Now we're gonna move it over. So we can now divide 585 divided by 7. If we do that, we get 83.571. Now if I want to round it to the nearest hundredths, that's 2 decimal places over. That becomes 83.71 over, now we're gonna put this over 1 just because we're comparing 2 rates. Now if I look at this, since we're comparing 2 rates, what does this number mean? This number here means they drove 83.71 miles per 1 hour. So the average rate of change between hour 3 and hour 10, including units. So the average rate of change between 3 hours and 10 hours was 83.71 miles per hour. And that's it. Remember, a lot of word problems, you want to write or end your answer in a statement. Okay, let's take a look at the last two. So first we have this one here. On the set of axes below, draw the equation of the graph. So the first thing I want to look at is I want to look at this equation right here. And I want to think, is this in, we have 2 forms for linear equations. We have standard form, or we have slope intercept form. So if I take a look at this, I notice that this equation is written in slope-intercept form. So I'm going to try to graph this using the slope-intercept way. If you have a preferred way to graph, you can always do that as well. So reminder, slope-intercept form means we have y equals mx plus b, where if we pull it out, m represents your slope, and b represents your y-intercept. So if I look here, I can see that from this equation here, just looking at how it's written, the slope is the value before the x. So m is equal to -2/3. And then our y-intercept right here is equal to 5. So if it's in slope-intercept form, and we know that it's like that because the y is by itself, we can just plot the y-intercept. So if the y-intercept is 5, I look at my graph, where is 5 on my y-axis? So this is my y-axis. This is my x. This is my x-axis. So I'm going to go to the y-intercept. I'm going to go to the y-axis. I'm going to look for 5. And that right there is my y-intercept. Boom. First point is there. Now we know the slope is -2/3. So I'm going to rewrite this in a little different way. I'm going to write m is equal to -2/3, which is almost the exact same thing. But this time I'm going to write next to it rise over run. So if I start at the point that I last drew, my rise is -2. So typically when you rise, you go up. But since our rise is negative, we're going to go down. So we're going down 1, 2. So right now I'm here, but I haven't gotten to my point yet. Our run is +3. So since it's +3, I'm going to go towards the positive numbers, which is going to be to the right. So we went down to 1, 2. Now we're going to go to the right, 1, 2, 3. So this here is going to be our next point. Right there. And then we're just going to keep repeating this, although all you need is 2 lines. We're just going to keep repeating this. 1, 2, 1, 2, 3. I'm going to get on my little word over there. We go again. 1, 2, 1, 2, 3. So once I have enough points, all I have to do is line them up. I'm going to try here because writing on this is a little weird. I'm going to line them up and I'm going to try to create a straight line. So let's try this. Pray for me that's going to be a straight line. That wasn't that straight, was it? Let's try again. That didn't work either. We'll try one more time. Okay, I think I know what to do. I just need to, all right, we need the straight line. This has to be a straight line. So what we're gonna do is I'm gonna do it over here. We're gonna try this one more time. Now, again, on the Regents or on your exams, take a ruler, take a straight edge. It's important that this line is straight. So I'm drawing a straight line going through all of my points. There we go. And at the end of it, you're going to make sure that you have your arrows. That indicates that this line goes on forever. Awesome. And there you go. You have that right there. So something I want to point out is that if we look at any of these points, any of the points here are solutions. So if we look here, this is 0, 5. So possible solutions. We have 0, 5 because it's on the line. We have 2, 3 as a solution. It's on the line. We have 6, 1 because it's on the line. These are all these points I'm talking about. Now, if it's not on the line, it's not a solution. Let me do this in a different color. So not solutions are example, I put a point right here. That one is -2, -2, +3. If it's not on the line, it's not a solution. And that could be anything. So I'm going to go with 0, 10. That's all the way up here. These are not solutions. Okay. Now, last but not least, on the set of axes below, draw the graph of the equation. Now here we go. If I look at this form right here, this one is not in slope-intercept form, but it's similar to standard form. So there's a few ways you can do this. Whichever way you prefer, go ahead. But since it's in standard form, I'm going to do the intercepts method. So I'm going to find the x-intercept and the y-intercept. So let's start with the y-intercept. At the y-intercept, x is equal to 0. I'm going to say y-intercept. At the y-intercept, the x is equal to 0. So we're going to plug into our equation. We have 3y equals 4x plus 6. And again, we're going to plug in x equals 0. So 3y is equal to 4. Now we have an x. We're going to plug in that 0 times 0 plus 6. Now we have 3y is equal to 4 times 0 is 0. All we're left is 6. Divide both sides by 2 to get y by itself. Y is equal to 2. So our y-intercept is 0, 2. Now we're going to find the x-intercept. At the x-intercept, y is equal to 0. So again, we're going to rewrite that equation. 3y is equal to 4x plus 6. 3 times, this time y is 0. So I'm going to plug in 3 times 0 is equal to 4x plus 6. 3 times 0 is 0 is equal to 4x plus 6. I need to get x by itself. So I'm minus 6 to both sides. I'm left with -6 is equal to 4x. I'm going to move this over so we have some more space. And I'm going to bring this up. So I'm going to rewrite this. We have -6 is equal to 4x. We're going to divide by 4 to both sides to get x by itself. So we have -6 over 4 that can reduce to -3 over 2. No, -3 over 2. Or if you just want to divide, you can divide -6 divided by 4 or -3 over 2. You get -1.5 equals x. So our coordinate for the x-intercept is, our x is -1.5, our y is equal to 0. So we write it as -1.5, 0, and we plot these. So our y-intercept, I'll do this in red, was 0, 2. So I'm going to go to my graph. I'm going to go to 0, and then it's 0, 2. So I'm going to go up 2. This right here is our y-intercept. Now, the second is the x-intercept. The x-intercept is -1.50. So first I start here. I'm going to go to -1.5 on the x-axis, which is right about here. And 0. So I'm not going to move from there. Here we have 2 points. All you need to graph a line is 2 points. I recommend if you can get more, you try. But since we have these 2 points, what I'm going to do now is I'm going to connect these 2 points. I'm going to make it as long as possible. So this is 1, and I'll extend the line this way. And that right there, that is your line using the slope-intercept form. If you want to figure out some solutions, we can take a look here. Oh, why didn't it? There we go. That's your line right there. If you want to figure out some solutions, we can take a look. We have, it doesn't go through the origin. So 0, 0 is not a solution. It goes to 0, 2, that's a solution. It goes to 2, 5 right here. So that's a solution. It goes to negative 1.50, that's a solution. We even have -5, -5, that's a solution. So anything on that line is a solution. If it's not on the line, it's not a solution. So that brings us to the end of the review sheet. Please look back, review this before the exam tomorrow, so we have full time and full credit and a full understanding for what's going to be on the exam. Have a great day, everyone, and good luck.